Let me explain you what is factor analysis. In factor analysis, you are trying to find presence of latent variables, which explains the pattern of observed behavior, observed variable. What you need to understand that you assume these latent variables to exist, maybe like core belief system. Maybe everyone the way they behave as per their core belief system. But you can't measure it directly. And that's what you're trying to assess. That's what you're trying to find. When you are not sure that how many latent variables exist and what are their nature, you conduct exploratory factor analysis because you are trying to explore how many factors are there so that you can use them. However, at times you have rough idea that these many latent factors should be there. And the only thing that you are trying to check that these many latent factors are really there or not. So you are trying to confirm the number of factors. At that time, you are conducting confirmatory factor analysis. This is called CFA. Most of the time you do EFA, exploratory factor analysis. For successfully doing factor analysis, if you are looking for say 3 factors, you should roughly look for at least 9 to 12 variable, 3 to 4n variable, and at least 5 to 10n data points. So for 3 variables you should look at least 15 to 30 data points. And factor analysis assumes normality of data, so you should try to use it with interval data. It's not a good tool for ordinal data. However, in practice, when you have a scale which is 5 or more, it can be treated as numeric data, and very much the way you have converted earlier, when you converted ordinal variable into a scale of 0 to 1, you can take it. One thing you need to understand in both PCA and factor analysis, there is no way to determine the factors. You actually end up looking at eigenvalue, proportion value, scree plot, etc. and then you decide how many factors are coming. Once you have got the factor, then traditionally you examine the variables that load heavily on that factor. So let's say if there are 2 factors are coming which are coming important, then you look at all the variables which load heavily on those factors, and then you try to decide what construct is common to these variables, and then you try to name the factor, because if you know that okay, these 3 variables are loading heavily on this particular factor, you try to name this factor that this factor is trying to measure this particular latent stuff. You will understand this better once I show you the same with an example. Keep in mind there is a lot of similarity between PCA and factor analysis. However, their intent is different. One is all about artificial variable, whereas another is all about finding the latent variables. You will understand it better when you see PCA and factor analysis side by side. So in PCA, let's understand similarity and dissimilarity. Both work on the basis of finding factor, eigenvalue, etc. and this is how you do in the factor analysis as well. However, in the principal component, here the principal component doesn't have to make sense always. These are just artificial variable. Whereas in factor analysis, you try to make a guess that okay, what this factor is trying to measure. You try to make a judgment about the latent variable. So here you are looking for the meaning in the latent variable, where you are not looking at. These are just artificial variable. Mostly you will end up deciding number of components, that how many components you should have. However, in this case, once the factor has come, your job does not stop here. You try to gauge which is the latent variable. You try to look at which are the variables which are loading heavily on those factors, and then you try to give a name to the latent variable, because you are trying to understand what this factor is, what this latent variable is.